welcome for today's online academy. Today I want to show you a proper way how to create handle principles, and therefore I was choosing an example for a handle from the Häfele website. It is this handle, and I will create two different handles in two different lengths. So I will take the 128 millimeters and I will take the 320 millimeters later. So first of all, on this website here, I am able to download the cut files for this handle. So here I can choose a format, choose DWG, and then I can download this drawing, save it to my folder, and here I can open this drawing to prepare it that I'm able to use it for IMOS. So this is what we have. So usually Häfele is hiding a tiny little Häfele logo on the insertion point, which you can see here. So this logo is actually a block reference. We don't need this one. So I will delete this out of my drawing. And then I will take a look at what object type the handle itself is. So this is also a block reference. Usually we try to avoid having block references in our connector drawings. So this is the reason why I will explode this. And after I exploded this, I get a 3D solid, which is pretty good. And the next thing I would like to change is the orientation. So I would like to rotate it in 3D, and I will rotate it in a way that it's standing upright with the drillings facing the bottom. And another thing that is also important, or one of the most important things, is the insertion point of this drawing, which is the 0 coordinate in my drawing. So I want to have the first drilling here being on the insertion point. So this is actually the point that I want to use. And now I will move it to 0, 0, 0. So that now my insertion point is directly here on the bottom of this drill. And to make it look nice, we will check what colors we have here. So usually this handle should be using an AutoCAD material. I will assign one from my material browser. I will just assign a satin color. This one should be okay. So now this color is assigned, and I put the color by block. Otherwise it can happen that this handle will appear in the layer color of the connector. So like this you can avoid it to have a different color than you actually assigned. Okay, so now my drawing is prepared. I will purge the drawing. I will purge everything unnecessary out of the drawing. So I type in purge, and I see that I have some blocks here that I can purge, and I will purge all checked items. So now I just have to save this drawing to the right destination folder here in my library. I will use my con.dwg folder where all the connector drawings are located, and now I name it Online Academy Häfele Handle underline and my article number is this one here. So I usually use the article number also in the connector drawing name. Like this, it's easier to find it if you're looking for the article number. So I save this handle and now I can set it up. So I switch to the element manager and I switch to my connectors here. Let's create a folder for Online Academy and a subfolder for handles. And then I will take the standard connector just to show you how to set it up from scratch. So here I could say my handles should always be visualized from Viso mode 1, which is quite important. Oops, no, I overwrote my standard connector. I should rename it first and move it to the folder. So, and I also have a preview picture which I downloaded from the Hairfiller website as well. It's this one here. So I want to use this picture as a preview for this handle, and this picture should be located also in my library folder. So I just copy it to my library, info and bitmaps. This is where all the connector preview pictures are located. And now I can assign it here. This one. So now I can see it already here on the top. And of course I can assign all the necessary information that I want to have here in my connector that can show up on part lists, for example. And I will also take this information for my second description, and my article number is this one, 11029901, and the supplier is Hairfiller, and the color is aluminium. So far about the commercial informations, and now we have characteristics. So each handle should have the fitting type handle, or actually here it's called pull, and it should at least have one constructive characteristic or connector characteristic, which is the drill distance. So here we type in half of the drill distance that the handle actually has. So my handle has a drill distance of 128 millimeters. So half of this is 64. And like this, I can show you later what this is used for. And I also need a group, obviously. So this is assigned to part number 0, and I need a work group here. So I will create one that I also call Online Academy Hairfiller Handle to drillings 128 millimeter. So my first machining is a hole on the insertion point 0. That means it will later be on the insertion point of my drawing itself. And the diameter is 5 and the depth is 0, which means it's always a through hole. So I save it like this and I duplicate this one, and the next insertion point should be on 128 because the next drill is on 128 millimeters. And it's the insertion point X. So I assign this and I save my connector again. So here you see that the orientation of my handle is in X direction. So this is why my insertion point for the drilling, the second one, is in X 128 millimeters, and the first one will appear here on the coordinate 0, on the insertion point of the drawing. Okay, and the last thing I will assign here in my connector is the drawing name itself, which comes from my con.dwg folder, and it's this drawing here. So I also save this. I copy the name and I create a connector set. Wait a second. Okay. So I have confused my databases. My database is in German, but that doesn't really matter. So this is actually my handle connection, and here I will create a folder for Online Academy, and then I take any connector set here as a template to create my connector set out of it. So I rename this to the same name as my connector has, and maybe I also should add the drill distance here. So like this, it's easier to distinguish them in the connection scan later. So here I will add my connector. Online Academy have a handle and the article number. And the attributes that we need here should be the fitting type is a handle. My drill distance is 128, and I will also use an additional filter, Online Academy, so that the connection scan will later only find this handle here. And the last, one of the last things I need is a connection situation. So I will create a folder here for Online Academy and a folder for handles. And then I create a connection situation which I call Online Academy handle. Yeah, just handle. Save it and move it. And here I can now set up that I want to use this connection with a connection scan. I don't want to use a direct selection in this case. You could also do this with variable connectors in your connector set, but I prefer to use the connection scan in this case, and then I have to assign my connection type, which is my handle connection. So it's this one here, which is unfortunately in German now. Yeah, but this is my handle connection, and then I can type in a linear division. Actually, this handle is a surface connector, which means that it needs two linear divisions. So the first linear division is the division in X, and the second linear division is the division in Y, which means the first division is for the height and the second one is for the width. This is referring to the part rotation. So if you have a part here that is, for example, a door, you see that a door here has edge 1, the vertical edge on the right side, and edge number 1 is also the X direction of the part, and edge number 2 is the Y direction of the part. So this will be the first linear division and this one will be the second linear division. So I go back to my connection situation and I say I want to have this handle in the middle of my door. So in the height, it should be in the middle. And then I activate the second linear division. From the edge, I want to have a distance of 50 millimeters to 1. And then I save it. I leave the rotation angle on 0. And everything else I keep on default except my attributes. I say that the fitting type must be a handle. And my additional filter 1 must be OA for Online Academy. So like this, I will only find my one handle connector set later. So the last thing I need to set up is a principle for handles, which is located here in hardware and machinings. There we find pulls and locks. So here we can define a principle that we can also call Online Academy handle. We save it, and then we say that the type is a pull. It could also be a lock, and then we can assign a connection situation to it, which is the one that I just created, Online Academy handle. I assign it, I save it, and I leave out the pull heights for now. I will show you later what this is good for. Okay, now I would like to try this out. So of course I need a construction principle for a door. I will create a folder here, Online Academy, onset, single doors, and then I take one of these templates here. So I just rename it to Online Academy Construction Principle SDO for single door onset with CH, cup hinges, and a handle in the middle. So I save this and I move it to my folder. And then, I don't really care about the part definition and all the other settings. So this is just an onset door, hinges on the left side. And here I have a connection situation for my cup hinges. We don't really care about this in the Online Academy, but we care about the handle principles. So here I will assign the handle principle that I just created, the Online Academy handle. I assign this here, and then I will create a small article that uses this construction principle. So I switch to my article designer, and let's say we have a width of 1000. We have a small carcass here, and then we have a divider, a partition in the center, and on the left and the right side we will have a single door. So my Online Academy door. On the right side I want to have the hinges attached to the right, and then I copy this whole group and paste it into the other article designer group, and here I say my hinges are on default, and then I just insert this article into my drawing. So here you can see my handles already. So what is interesting now is that these handles are in the middle of my doors, and I will draw a line here to check the height of the handles. So this line is on 1000, My article has a height of 2000 millimeters, so now you see that this is exactly the middle of my door. And so far it's nothing special, but what is quite special is when it comes to rotate the handles. So maybe you don't have vertical handles all the time, and at some point you might want to rotate them. So if I select both of these handles, and here in my Explorer I switch to the connection of this handle, I can type in a rotation angle. So here I will just switch to 90 degrees, and then I get this result. So basically I would have to rotate them and move them. But actually I would prefer that now my insertion point is on 50 millimeters from the edge without changing any linear division. I just want to rotate it. So let's see how we can manage that. I will just delete this modifier for rotating the handles, and then I switch back to my connection situation, because here we can do some special settings which are quite interesting. For example, here we see that we can choose a reference for the first linear division. It's on please select. So we can choose between centric, the first insertion point, and the second insertion point. So actually I would like my first linear division, which is for the height, to be in the middle. Here on this preview picture you see, okay, that it now calculates from the first insertion point to the middle. It can only do this because in my connector itself I'm using my characteristic for the drill distance of 65. So it knows the insertion point is here, and from here it has to add 64. I'm sorry. From here it's adding 64 millimeters. So like this, we can work with a reference for the first linear division, and for the second linear division, I say I would like to use my first insertion point, which means that for my 50 millimeters to 1, it's always referring to the first insertion point, and my first insertion point, as you can see it here, is here this blue square. So this will always refer to my second linear division now. So when I rotate my handles now, both of them at the same time with the same rotation angle on 90, I still get the same result. I hope you all know why this happens, because I didn't refresh my article. So first refresh your article when you change some basic data, and then we can repeat this. So select both of the handles, and now we type in the rotation angle, and now you see that they always refer to the correct insertion point, which makes it a lot easier to handle your handles. Like this, you don't need complicated formulas for your linear division where you play around with variables. Now you could just type in the value here. If you need 100 millimeters or something, then it will always be this value from the drill distance to the edge of your door. So you don't need a variable in your linear division that calculates the drill distance plus the offset that you want to have. So here you see I have 50 millimeters to my first drilling, and this is not only handy when you're using one handle. So this is where I will set up the second handle. So let me choose from here the 320 millimeter handle. Okay, now it should update it here. Okay, so the dimension C, as you can see here in this picture, is my drill distance. So now again, I will, they have no cut files for this. Okay. Then I need to take another handle. I think I have another one here. So let's check out this handle. It's a quite similar one with a drill distance of 320 millimeters. And yeah, herefore I have the drawing already, so we can take a look at this drawing. Of course, it's also important that the drawing is also oriented in the same way as all the other handles are. Like this, they will behave exactly in the same way. So let's create this handle. I will copy the name here. And then I switch back to my connectors. Save this one, and then I also change the drawing here. And I need another work group, which is for 320 millimeters. I apply this and I save it. Maybe I choose another preview picture. Should be this one. Okay, so I don't care about the rest of the commercial informations for now. I will just create my connector set. Okay, so the article number here is wrong. Let's delete it. I just call it handle 320 and I replace the connector in this connector set. And I also change the drill distance here. This drill distance for now doesn't really have any effect. If you wanted to, you could filter for the drill distances in your connection situation. So you could use the drill distance here to filter for your 128 millimeter handles or for your 320 millimeter handles or whatever. Or you could also set priorities if you wanted to. You could switch to your connection types, and in your handle connection, you could say, I have a priority, which is, for example, 10, and I want to sort them ascending, which means it would always, the connection scan would always take the handle with the shortest drill distance. We can just leave it like this, we can try it out. And so now I have my second connector set. I should be able to use it already. So I go back to my article. I refresh my article, and then I will do a connection scan. Actually, I will delete the modifiers that I used here. So now my handles are back in the vertical position, and then we can do a connection scan to see what the connection scan offers us. So here I have my handle connection. You see both of the handles, 128 and 320. So if I choose this one, I get this result here. So now you see that this handle is not in the center because I went a little bit fast. I forgot to change the characteristic in my connector. So I still have the drill distance here of 64. Of course, this should be 160, half of the 320 millimeters that the handle actually has. So I changed this, I refresh it. Now we can also see the difference. It just goes down a little bit. And if I now rotate these handles, no matter how long they are, just need to make sure that my door is wide enough. I can change the rotation angle to 90, and then it also rotates in the same way as my other handles, because it always refers to the first insertion point for the second linear division. So this is a quite important thing, I guess, when it comes to setting up your handles. And now we can take a look at the drawer heights, the handle heights, or the pull heights as they are called in the Element Manager. So let's go back to our handle principle. Here you see that you can add a pull height. So if I click on the 3 points, I can set up a pull height. Save it. So you can add a list of different heights here. Let's for now use only one height. Let's say we use 1200. So we activate the height lines, which means that these lines are actually in use, and we can use a snap radius, and we can use a top distance and a bottom distance. First I will assign this, and then I will explain what these settings do. So I save this to my principal, and when I refresh my article, then my handles jump up. So this line is on 1000. If I just copy this line to 200 millimeters offset, you see that these handles are in the center of this pull height. This is because of the settings in the pull heights principle. So here you actually have a snap radius. That means if the insertion point of my handle is inside of this radius, it will move them to this pull height. And these are minimal values that may not get smaller. So if my pull height here would 1200 would be here close to the edge of my door, and if the distance would be less than 50, it would not move them to this pull height. It would let them stay where they are. So, and when I use my other handles again, They are also on this height because they are also in the radius of this of these 200 millimeters. So let's take a look at handles for draws. I will create a second connection situation. And I just name this Online Academy handle draws. And I also create another handle principle. Save it, and then I assign this connection situation to it. I delete the pull heights out of this one, and then I need a draw principle that is using this handle. So here I assign my handle principle for my draws, save it, and now I will modify this article a little bit. So, or maybe I just create a new article that is a little bit better for the overview. So I just insert one drawer here, which is the one that I just created. Online Academy two-side frame system. And the height of this article, let's say it's 400, the width is 500, and the depth is 500. And then I have an onset drawer, and I insert this drawer into my drawing here. So now you see that the handle, of course, is oriented in the same way because I didn't change anything in my connection situation. So there are some things that I should change if I want the handle to be horizontal on top of my drawer front. So let's go back to this connection situation. Online Academy handle draws. So I will just switch the linear divisions because in this case the handle should be centered to the middle of my drawer. So I have 1 to 1 for my second linear division, and I have 1 to 50 millimeters for my first linear division. So this is actually the same part rotation for drawer fronts. Edge 1 is the right vertical edge. Edge 2 is the horizontal top edge. So this is my second linear division. This is my first linear division. When I refresh my article, my handle should be still vertical, but now it's centered to the width and it's on 50 millimeters to 1 with the middle of the handle. So I should rotate this handle. Let's say I want this, my drawer handles always be horizontal. So I just type in a rotation angle of 90 degrees. And then you see that my first insertion point is in the middle of my drawer front, which is due to the references that we are using. So here we should just change these references as well. I would like to have the reference of my first linear division, which is for the height. I want it to be this time on the second insertion point. and the one for the second linear division for the width, this should always be in the middle. The reason why I choose the second insertion point for the reference of the first linear division is the one that, in case if I would rotate this handle 90 degrees, it would rotate around this second point, because my first insertion point is on the right, and now it would rotate it around this axis. Let's try it out. So I just have to type in 90 degrees, or actually 0, and then it rotates like this. And now I have my 50 millimeters from the top, and my handle is still in the middle. So there are a lot of things that you can set up in your connection situation for the handles that make actually a big difference when it comes to to customize your handles, or when you need to rotate them, or you need a different offset. Sometimes it can be quite complicated to set linear divisions when you have the wrong settings here. Then you start playing around with variables for the first linear division and for the second one and for the rotation angle. So when you set up this correctly, you make it a lot easier. Yeah, now I'm at the end of this online academy. I hope it was helping you a little bit. And if you have some questions, I will leave the chat open for a while. And yeah, I hope you have a great day, and I hope I see you again next time. Bye bye.